Hey everybody, welcome to Double E's Talk Tech. My name is Daniel Bogdanoff, and I'm here with Mark Lombardi. Mark has been around the Keysight halls for a little while now, and we actually, a couple years ago, I had never met the man, and through a weird twist of fate, like a friend of a friend of a friend, we ended up on like a 17 or 19-day Grand Canyon rafting kayaking trip. So if you've been with me a while, you know I took a couple weeks off back a couple years ago, and Mark was actually on that Grand Canyon trip. And then we came home, and we haven't really talked since, to be honest. So.
You know, we have other things to do in life.
It's true. Yeah, and you're in Santa Rosa, and I'm here in Colorado Springs, and you're out here for the day to give a talk on space, which is kind of your specialty right now. So tell us a little bit about yourself.
So my name is Mark Lombardi, and I have been working for Keysight for about 25 years or so, and from working with power supplies all the way to high-frequency RF gear. And I took a little sabbatical and worked for a customer of ours called RT Logic for about 5 years and got deep into the space industry. And came back to Keysight, and now I'm applying that, helping our company figure out kind of what are the right products to do to help enable the space economy.
Yeah, so the space economy is just a whole new ballgame, right? Like you look at emerging markets, and you probably know better than I do, like as far as like economy growth and opportunity for jobs and companies to support and build an infrastructure around, like the space economy is just blowing up. Hopefully not literally, but can you speak to that a little bit?
I can, and the blowing up part, things have been going pretty well. You know, I always tell people your odds on Everest are worse than going up into space right now. So, things are pretty good. But
and probably costs about the same, right? Like a couple hundred.
Yeah, right. It's going up now. The permits are getting crazy.
Are they?
Yeah.
Okay.
So anyway, what's happening is really exciting. The first trillionaire is going to come from the space economy.
Interesting.
Because what's up there in resources is unbelievable. More than on our planet, we have resources. And it seems kind of crazy to think that we are in a place now where we can actually go collect those resources. Yeah. We have never been in a position to be able to do that before. But once you get out of the Earth's gravity and you can move around, get out to the asteroid belt, bring back resources, and work with them.
So so space mining essentially is what does that? So in my brain, when I think of space mining, I think of like the big value of that is that you already have materials in orbit. Is it like you say the first trillionaire? Are they going to be bringing stuff back down to Earth to harvest?
Yeah, it's a good question. I think it's going to be how well do we establish manufacturing in space.
Okay.
So there's this idea of going to the moon, going to Mars, as basically establishing humans as an interplanetary race.
Oh, okay.
And in that path, there'll be stages, right? So if there really truly is a space economy, then we'll be in a situation where you'll need those resources up in space.
Right.
There's even radical ideas like, well, if you actually built satellites on the moon and launched them into the Earth orbit from the moon, you have less energy.
It's all about price per pound, right? Into orbit.
Exactly. That is the driver. And that's why what Blue Origin's doing and SpaceX are doing are so exciting, because they're landing rockets and reusing them and driving that cost down to, what they're trying to do is 2 magnitudes down in cost for lift.
Sure. So that's crazy. So you could do, so you have like microgravity, which would be like the space station or in orbit, and then you have low gravity, which would be something like the Earth or Mars. So you could do manufacturing in low gravity, which would make things much easier than trying to do it in like microgravity, right?
That's not really an area of my expertise, but I think, that's all areas to explore. Once we can get into space in an economical way, we can start to look at that. And really, the cool thing about being involved with space right now is it's a blue ocean, right? It's it's a little bit like the California gold rush plus, maybe exploring the Arctic for the first time, and just an amazing correlation of technology and means and human desire, quite frankly, to do it.
That makes sense. Yeah, interesting. That's crazy. So what will... So first off, I guess if you want to be the world's first trillionaire, get into the space industry and have a couple $1 billion to get you kickstarted is probably the big thing, right?
That helps, yeah.
So,
but it should turn a profit. If you look at what's going on with SpaceX right now, he's going to be the way that the U.S. gets back into space with human flight, right? So we're counting on that investment. And then also satellite investments, plus the rockets that you see and the ultimate goal of a Mars mission.
For sure. So you bring up satellites, and that makes me think of Space Force. Can you speak to that a little bit? Because I see, it sounds a little silly, and the media kind of portrayed it as this like thing, but
yeah,
it seems very reasonable to me that should exist.
Well, it's funny, when I first heard it too, I think I had the same reaction as you. And because I really follow the space industry for Keysight, and I really need to seriously look at all the opportunities, you actually look at it and there is a sensible question, and that is the armed forces, the various different branches, like the Air Force and Navy and Marines, all need satellite resources. They need the observation capabilities. They need the communication capabilities. So you have a choice, right? Do you distribute the management of those resources in different branches, or do you bring that into a central place? So it's a really interesting question, and I think it's being worked out as time goes on. But it makes sense, right? That how do you manage those assets? And those assets are really important to our future. You could say it's important to governments for their safety and their sovereignty, but the other piece is it's important for our humanity, right? The communications, so branching out into more of what satellites can do for us.
Okay, yeah, that makes a ton of sense. So how do you test the things going into space? Because I feel like, in the 60s, space and getting to space was almost purely an applied physics challenge. Like, sure, there were definitely engineering challenges, but so much of like getting the orbital dynamics right and but it's now turned into an engineering problem, because now you have these complex satellites up in space.
Yep.
And the communication side of things. So what are people struggling with, and how are they going and making sure that what they put up there is actually going to work in space?
Well, you better be careful what you ask, because this could go a lot of ways. But I'll start at the highest level. What's really changing in space is it's going from a government-only activity to a commercial activity. And so business people are looking at, how can I use space for making a profit? How can I add value to society? So those questions are very different than they've been. And that propagates all the way down the chain. So the test is a piece of that. But why I said it's going to get complex, and you'll have to remember to bring me back on some of these trails. But the thing that you have is you have this time where there's radical things changing. We have rockets that are being reusable, driving down the cost of lift. We have things like phased arrays, why are those important? Well, remember the old mechanical antennas that tracked on your vehicle, like an RV or something, to track a satellite? You're just not going to get that far with that kind of technology.
Interesting. Well, I know to ping the space station as a ham radio person, you have to have your antenna tracked, and you have to get the phase shifts all right because of the Doppler effect and all that. So
exactly. And so that's another big shift, is the move from geosynchronous satellites, where you could just park an antenna like you see on satellite TV, to these low Earth orbit satellites, which now you have to track to be able to contact with them. But what the advantage is those are much closer to the Earth.
Sure. So power requirements are lower, and
Power is one, but latency is another thing that's really interesting. You have a 250 millisecond latency up to a geosynchronous satellite.
Wow. Okay.
So for backhaul, it's fine, right? For video delivery, you do a negotiation. I want to watch a movie. It comes down. That 250 milliseconds, you don't even notice.
Yeah. So I was actually reading about this last night in a 5G article, but essentially right around 50 milliseconds is where humans can perceive it. So like if you're trying to do like haptic feedback on something, like you're controlling a robot and you want to like have it vibrate when it hits something, about 50 milliseconds is the maximum amount of latency before it starts to become noticeable. So, sorry.
No, it's a great point because you mentioned
so 250 is a ton.
It's a ton, right? And for certain things, for the way satellites have been used, it's been okay. But for satellites to play an equal part to a terrestrial infrastructure, and you mentioned 5G, 5G is one of the interesting, exciting parts of where satellites are going to go. Just think about it. Today, do you have ubiquitous connection with your cell phone?
No, not really.
But that's part of 5G. They want that to be anywhere,
Global
everywhere.
coverage,
Global coverage. That's going to come from satellites. So if you can put a satellite into low Earth orbit and now bring that latency down to 30 milliseconds or 20 milliseconds, now you have something that, as you said, it's below that 50 millisecond threshold.
Right.
And it
For
can
humans,
play as it can play as an equal in the communication backplane.
That's pretty cool.
Yeah.
Yeah. So that makes sense. So yeah. Sorry, my wheels are spinning.
Well, they should, because it's a big challenge.
Yeah.
Because think about a low Earth orbit satellite. It's coming around the Earth, and the Earth is spinning. So if you only have one of them, you're only going to talk to it a couple of times a day from one spot on the Earth. Well, if you really want coverage, you have to talk about hundreds of satellites. And when you're talking about hundreds of satellites, you're talking about a revolutionary change in how you approach doing satellites.
And we touched on this. We had a podcast previously where we talked about CubeSats, and specifically for weather. So I went to a launch in May, which was
And you didn't invite me?
amazing. I didn't invite you. They were very specific about, like, I got a media pass, and they were like, you get just you, no one else. But you, honestly, Richie would have been second on my list because I would have loved to have like a video guy.
But I have some dirt from the river, you know.
So it's true. It's true. Yeah, you can hold a boom mic or something, right?
Yes.
Yeah, you should check it out. I bet you could get a pass for it.
Well, now
cool.
I've got an in.
Yeah, there you go. Right, an in. Yes. But they were talking about satellite CubeSat systems that were essentially, they'd go like a train basically. So you could, instead of trying to measure like the weather as it developed over one point and have something geosynchronous, they basically just passed a bunch of CubeSats over it in a specific timing, and then they could watch it change over time. So and you can also do it much smaller and cheaper that way instead of this giant, phased array. I said phased array. That's not what I meant. Giant like satellite in space.
But you could do phased array too.
Yes.
That's the interesting dynamic. First of all, the CubeSat really changes the dynamic. One of the things I followed was the country of Ghana recently launched their own satellite. And
the GhanaSat.
Yeah, and think about the enabler that brings. It brings a capability to a country. They can control their own destiny. And what they're thinking of for the next launch is to try and track for poaching and other things, right? Things that are good for the country.
Super specialized.
Right, super specialized,
No one else is really going to do that for them.
Right.
So it makes sense.
But it's within their reach now.
Yeah, that's crazy.
Because those satellites can be built for $100K or less.
Right. Okay, electronics hardening. That's a thing, right?
It is a thing.
Because space, we have this nice, magnetic field over the Earth that protects us from radiation. But as soon as you throw that up in orbit, you're basically pulling the shield away. What does that entail? What does that look like? How do you?
It's a good question. I'm glad you just keep throwing things at me.
Sorry.
See if I can work on my toes.
We obviously don't plan these, so I should also, I meant to do this at the beginning.
Yes.
If you're listening to this, it's December now. It's the day before Thanksgiving for us here. I want to apologize for not having a podcast in October or November. It's just been crazy. Life is crazy. I more or less produce and plan the podcast, and I have someone help edit, which is awesome. So thank you for helping edit. So trying to keep this podcast going is something I definitely want to do. I want to shift the format a little bit. So I'm more, I don't know why I'm talking to you.
That's cool. Okay,
So
talk to them.
to the fans of this podcast, we're going to try and shift to once per month and do a longer format discussion. Historically, it's been like we've tried to shoot for like a 20, 25-minute podcast. The discussions tend to go more like 40, 45 minutes. Mm-hmm. So in general, we're going to switch to once a month, and that should be much more doable to keep this maintained, and that will hopefully open up some of my time to create a test and measurement specific podcast instead of just a technology podcast, which is something I really want to do, and it's just not been on my plate. So we're switching to once a month. If you have comments or questions about that, put them below, but we will get to you once a month for sure. And that will also open up, Christmas is always tricky. Like, do we post a podcast the fourth Thursday of December or the fourth Thursday of November, which is, Thanksgiving? No, because no one's really going to listen. And so once a month is what we're switching over to. It makes me a little sad, but also I think there's a lot of opportunity there. So sorry for interrupting.
No, great. But
yeah.
you brought up a great topic, which is rad hardening. And there's a lot of interconnected discussions on that too. So
I'm sure.
Again, radical change happening. So think about the old way to do a satellite. You would be building a satellite, significant investment. You would be planning to put it and keep it up in orbit for 7, 10, 15 years, 30 years, right? So radiation hardening is a critical part of deploying that satellite. The problem with radiation hardening is you have to make trade-offs with the components. For example, it's very difficult to get a rad-hardened, high-speed, cutting-edge CPU or FPGA. They just don't exist. So you have to scale back your expectations of what you can do in space.
Interesting.
Based on that.
So almost when you need the most high-tech technology available,
can't have it.
You then can't have it because space will just wreck it right away.
Exactly.
Interesting.
So, but there's tons of innovation going on there. Besides doing new things with rad hardening, the other thing is think about the LEO satellites. Now, they're not as high in orbit. They don't get exposed to as much radiation. And if your lifespan is only going to be 1 to 5 years, you might actually be able to deploy some technology that you wouldn't normally deploy. Now, you still, they talk about rad resistant or the ability to be able to recover from some errors, but it changes the dynamic completely. We might
that
take,
makes sense.
And you can
LEO, by the way, low Earth orbit.
Low Earth
LEO,
orbit, yes,
so.
That's right. Yep.
Yes.
Sorry, too deep into it.
Yeah.
Well, next time when we do kind of the whole technology thing, we can talk about
definitely
that. Yeah.
Yeah. Okay. So basically, with LEO satellites, you can build in like a anticipated mortality rate of your CubeSats and just have enough redundancy to make sure you're not losing coverage for what you need. And okay, that makes sense.
But think about what else that does for you. A program that would take 7 years in the past, a satellite program, if you looked at what technology you had for example, imaging 7 years ago, what was that? The iPhone?
2011. So what? 4 years after the original one. So
yeah.
four-ish?
Right.
Yeah.
The pictures, the camera wasn't that great.
Brutal.
So somebody that was building a satellite on that time frame would be using that kind of imager, figuring out how to get the right lensing, get. Now, if we had a 6-month project, we could take the latest iPhone 10 and then take that imager and put it up in space.
That makes sense.
And so think about that technology role. If you can capture more of Moore's law, then you can build things that we haven't done yet in space or change the way we utilize space.
That makes sense. That makes a ton of sense. You sent me a slide deck that I looked through a little bit. There was a picture of this giant like chamber thing. Can you describe that and what it's for and what it's?
I'd be glad to.
Okay. It looked really cool. Maybe we'll post a picture. Hopefully.
Yeah, you can. Yeah. So there is a dirty little secret about space. It is space. It's cold.
Sure.
There's no air. It's a vacuum, right?
Right.
So how do you reproduce that on Earth? Well, those big chambers are how they do that. That's
Okay.
They put, they're basically large metal cylinders that they can seal up, pump all the oxygen the air out of them,
Okay.
and create a space environment.
So it's kind of a cold vacuum, basically.
Yeah, and that's an interesting dynamic. They call it a thermal vacuum chamber.
Okay.
That's another thing that's being questioned as everything's changing in space. Well, do you have to really deal with the temperature variations of space? It turns out that things like automotive parts are pretty good with temperature swings.
That makes sense.
So if all of a sudden you open up the door for other parts and other components, maybe you can change again the price point, the dynamic of how you do things. So there are ways to keep things warm and cool, and there are techniques to doing that based on the sun and the energy you have available.
Sure.
But the vacuum's the critical thing. You
Okay.
can't, if it's going to outgas, if it's going to cause problems because of that vacuum, that's kind of one of those critical tests.
So what happens to electronics in a vacuum? Because obviously, like, your circuits don't care, but bubbles and chips packaging or something like that, or
Sure,
what's...
right. They say like electrolytics, right, a can with air in it, that's a bad thing.
That
You
makes
kind of
sense.
have to get rid of all that. The thing that's a problem is the outgassing. If it's like an Earth observation thing where you're going to outgas and get crud on lenses, right?
Sure.
So if stuff's going to come out of it, that's a problem.
Interesting.
Yeah. Again, it's kind of stretched into an area that Keysight doesn't necessarily always get in, but we definitely help our customers test and make tests in that kind of environment, which is very unique. So it drives Keysight to actually think about how do we make parts and test equipment that can extend into that environment.
Yeah, because it's one thing to just throw it into a thermal vacuum chamber, TVC. I'm sure there's an acronym for it.
TVAC.
Yeah, TVAC. Okay. And see what happens, and after put it in there, vacuum.
Yep.
Escape all the air, and then afterwards see what happened. But it's another thing altogether to actually test it while it's in there.
Yeah.
And I imagine you could do some RF stuff and communicate that way with it somehow. But if you're trying to actually get in there and probe or something, that's got to be quite the challenge.
Yeah, it really is. It's a significant challenge because of a lot of reasons. You mentioned a couple. The one that's a real challenge for engineers these days is just as we go up in frequency, right? One of the things driving this revolution in the space industry is the want for more and more bandwidth, more and more data. And to get that, you have to go up in frequency. So as you go up in frequency, you have more attenuation. Even, of course, in the atmosphere you do, but even over cables, your cabling losses get higher. So if you're in a chamber 50 feet away, you may have so much loss in sending a signal to that satellite that you can't actually make the measurement you want, or vice versa, the energy coming back from the satellite. So there's all kinds of innovation and thought going on about how do you deal with those issues.
Yeah, that makes sense. So what are people doing?
Well, it's a good.
As much as you can say, I know that.
No, it's a really good question, and there's limited choices. You can just transmit with more power and deal with the losses, but that's hard because you have nonlinear problems as you amplify signals. They're not as pristine. You don't have the control that you want over them. People have switched to waveguide, so waveguide has less loss, but it's a pain in the neck to, right? All this hard, channeling that you're sending around.
That makes sense.
That's not easy. People are looking at optical. so electrical to optical, optical to electrical
That makes sense.
transitions.
Yeah.
And one of the other interesting areas is, one of the areas Keysight's been pushing into is modularity. And so as you shrink down test equipment, theoretically, you can get it closer and closer to the chamber, and possibly, if you can vacuum, right?
Is that in our future? Vacuum
I would love it to be. I think what happens is it's a as the space industry innovates, as there's more components, more capability that is designed for space, as the volume goes up, you'll have actually more component vendors making things that are space hardened or space tolerant.
Because basically, you would need a space-friendly piece of test gear.
Mm-hmm. Exactly.
One that you can actually send up in orbit with it, which is an interesting business opportunity.
It is. Yeah. Do you want to, pull some
let's
of our...
go. So what, is there test equipment in space? Surely there must be some.
Well, there clearly are some needed on the space station.
Right.
And that's a whole different, when you have human interaction with equipment, it's a whole different level of qualification. And it's something that, it's a long, lengthy process. But the point is interesting.
Do you know what's up there? I've always kind of wondered, do they have a scope on the space station, and what is it?
So I haven't, kept too much track of what's up there, but as needed, as you look at repair missions, right now, the space station and the astronauts are actually starting to do some repair work. In
and a lot
space.
of them are engineers, as their college training.
Yep. So I think that will change very quickly over time. Again, I keep coming back to if you hadn't heard one thing from me, this is a really fun time to be in the space industry because things are changing so rapidly. I think things that we think about that are fixed are no longer fixed, and so it's a really exciting time for us to be involved.
And I remember seeing a stat, and you probably know it better. What is kind of the size of the space business now overall, and what's its projected growth-ish? I know this is not.
Yeah. So don't take me. I put an asterisk by it, but it depends how you count it. One number that gets thrown around is $300 billion industry. Again, it depends on. It's not small, and actually, it's projected to go into the trillions as this. If you believe we will become a spacefaring civilization, then that economy could grow to trillions.
Sure.
And that's kind of what the forecast is. There's it's exciting to think. I think, there's some forecasts that'll happen in 20 years. I don't know. It'll all be to be seen.
How much does battery technology play? How much battery technology has to have a big impact on space stuff? So what does that look like?
It does. So the interesting thing is lithium-ion batteries work pretty well in space. And so they tend to use them where we have solar, where you can recharge them and discharge them, of course. The area gets interesting for deep space exploration is all kinds of crazy sophisticated batteries that don't need to be recharged by light. They use all kinds of fusion technique. That's an area I don't get into too much.
Yeah, and rechargeability has to be a big thing, especially with a trickle charge from a solar panel or something.
Right.
Giant. We're running up on our time here, but I know
we didn't even make any jokes about rafting.
Yeah, I know, it's true. It's true. Space is like rafting because electronic propulsion, is that a thing that could happen someday, and what would that look like?
It's happening faster than you can imagine.
So is it like a light sail type mechanism, or
no? It's the things of science fiction. It's ion impulse engines. It's it's Star Trek, and for me, it's so exciting. But they're basically using electrical fields to accelerate particles, right?
Interesting.
And so the key to that is energy.
Right.
So you need power. Solar technology you mentioned, some solar arrays. That's a big part of enabling. You need the power to be able to do those things.
Right.
but it's enabling satellites to stay on orbit longer because they have more potential energy that they can harvest from that kind of technique versus the old rocket engine techniques. Now, you did mention something about space, and I forget how you said it, but it triggered a thought, which was, electrical is the same. It turns out in the vacuum of space, when you get over about 150 volts, things get really interesting because the breakdown voltages are different in the vacuum of space.
Oh.
So those electronic engines, the electronic engines tend to be higher voltage things. So that it's an art to get from typical buses that may be 24, 30, or 150 volt buses up to the voltages they need for the.
Fascinating. I never thought about that because air's an insulator more or less.
Mm-hmm. Yeah.
Pipe it out, it's a different breakdown voltage. That makes sense. Any comments? There was just an astronomical anomaly, like a I'm going to use the wrong space term, like a meteor or something, and a couple professors were like, "Oh, it could be a alien light sail ship." Have you heard about that at all?
I'm a nerd. Yeah. I follow this stuff. I did see it. I think for me, there's so much we're still discovering, and we'll have mechanisms that are better enabled to go out there and send out robots and go explore those things. It's exciting. I think I'm going to put my money on let's see where the Mars missions go. NASA's landing something, I think in 2 weeks.
Pretty soon, yeah.
Yeah, pretty soon, and one of
probably right around when this podcast airs.
Maybe.
So you can let us know how it went.
Yeah. Right. So. Who knows? They hope to find some evidence of water and other things on Mars. So that's everything's game right now. Right? We're in a new place.
Yeah, it's really cool.
Yeah,
really cool.
Yeah.
Well, we're definitely out of time. So thank you, Mark, so much. Appreciate you coming out.
It's great seeing you again.
We'll definitely have to do this again.
Yeah.
Maybe we'll get a Lombardi update every couple months or something.
Anytime. I'd love to.
So thanks for watching. Make sure to subscribe to Double E's Talk Tech in your favorite podcast engine, and also on YouTube, the Keysight Podcasts YouTube channel. And tell your friends. We're really trying to keep this podcast alive and going. We love doing it, and we know we have a lot of you diehard fans also love hearing it. So we're going to do our best to keep this going once per month instead of every second and fourth Thursday. And that'll open up some space for some new stuff that we're working on. Thanks for watching. Daniel Bogdanoff, Mark Lombardi, and we will see you next time.